This is a little bit before we left off, but just to jog your memory, we were talking about sequences. Specifically, we talked about how we're going to work with the arithmetic sequences, okay? And then we started example 1 in those notes, right? So we understood what an arithmetic sequence was, and we were working on using information from the sequence to find out more information, which most oftentimes involves an explicit rule, but we also learned how to write like something like a recursive rule, okay? So your homework tonight is going to be on this. It's homework number 2. It'll be on Canvas. It's on the assignment sheet if you printed out the assignment sheet, okay? This is the topic it's going to cover. All right, so we started doing example 1, and we just got to the point where we kind of developed a formula to build the explicit rule. So we looked at the pattern that existed in an arithmetic sequence, and the fact that you just kept adding D each time made this pattern where you could get any term. So remember, A is a term. N is kind of not identifying a specific one, just some term in the sequence. You could get it by starting with the first term and adding D a certain number of times. And by looking at the pattern that we looked at on Friday, we established that that number of times was N minus 1. So if I'm looking for the 10th term, I would start with the first term and add the common difference 9 times. This kind of idea. Does that make sense to everybody? Okay. If you didn't write that down, write that down. This is an explicit rule or formula for arithmetic sequences. You can't use this for other type of sequences because it wouldn't work if they didn't have the consistent D being added to get to the next term every time. Okay? So then when we're looking at this problem up here, okay, we got to this point where we said, all right, if I want to write the rule, I need the first term, which they don't tell me. Okay. I need the common difference, which they do tell me. And I know I'm using that N minus 1 times. Now, if I'm going to leave it as a rule, the variables that my rule would contain when I'm done writing it is the output I get after I use this input. So I want my rule to have an AN and an N in it. That is complete. That's like an X and a Y, right? Plug in this X, get out this Y. That's what we're trying to build, an equation. But I can't have this also be empty, or else I haven't built a rule where you can plug in the term number and figure out the term. Okay? So for right here, we simplified this, right? You guys have some of these notes from last time. So this is what it simplified to be. As far as we could get at this point, that's the best we could do. But we do have another piece of information about this sequence. What's the other piece of information we know besides the fact it has a common difference of -7? Yeah. Good. The 7th term is 15. So think about what that means. Okay? This means when n is 7, then AN is 15. In other words, if I plug in 7 for N, I should get 15 out for A sub N, right? That's what's supposed to happen in the rule. You might not think that's very important, but that means I am allowed to put a 7 here as long as I put a 15 here, and it still all makes sense because they've told me that one true statement. How is that going to help me by plugging in that piece of information? Yeah. Then I'll be able to solve for A1. And that's not going to be my final answer unless they're just asking me to find A1, but they're not. They're asking me to write a rule. But then I have that other piece of information I need to write the rule. Okay? So I'm going to plug in 7 for N. Again, why am I picking 7? Because that happens to be the piece of information that they chose to give me. Okay? Oh, and I didn't do what I said I was going to do. I said I was going to plug in 7 for N. Notice that when you plug in 7 for N, this becomes A7, and they already told us A7 is really 15, okay? So this is 15. And you can see how we'll be able to solve for A1, okay? So this is 15 equals A1. So negative 49 plus 7 is going to be negative 42. I'm going to add 42 to both sides. And I'm going to have that my first term is 57. Now, kind of get off track because you're doing all this work to figure out more information. Go back and make sure you're answering the question. So we want to write a rule for the nth term. So my rule is going to say the nth term can be found by doing this. Okay? So the explicit rule is going to say 57, okay, minus 7n plus 7. I'm getting it from right there. Okay? But I can combine a couple of like terms to make that simpler. The 57 and the 7 can be combined together so that my final version of this rule would say the nth term can be found by doing negative 7n plus 64, or 64 minus 7n. So this is going to be a super important piece of information to know, okay, the general rule. And then you have to be able to read each piece of information as knowing what that means you can substitute into your equation to figure out whatever it is they're asking. Okay, and now if they ask me for the 100th term, I would just plug in 100 for n and do the calculation and go from there. Okay? Any questions on this example? Yes? Uh-huh. Uh-huh. Yeah. So when you plug it in for both ends, remember over here it's becoming a subscript. So it's just part of the name, a sub 100. And over here, it's a number multiplying this stuff and doing arithmetic. So at the end, your answer would say something like a sub 100 equals this. But that makes sense because this is just naming that it's the 100th term, and that's telling you what it is. Okay? Good? All right, let's look at the next problem. So then it tells us two terms of an arithmetic sequence are a7 equals 20, a23 equals 52. Find the rule for the nth term and the value of n for which a sub n equals 44. So a lot is going on here. Reading those directions as a student, what's your first goal? To obtain what? Information. What do you want to do with the information they gave you? Yep. Good. We're going to use that explicit rule to help us because, one, it answers the first question to write the rule, right? And then, two, it's the simplest way for us to then either figure out which n they use to get 44 or to plug in a different n and obtain a different term, okay? So I'm going to go ahead and do that. So the general formula looks like this. All right, so how do I get, for this to be finished, I want to have an equal to something where the only variable someone's plugging in is n. So I basically have to figure out my a1 and my d. How am I going to do that? Take 2 minutes right now in your group. If you know the 7th term is 20 and the 23rd term is 52, how would you figure out the common difference in the sequence and the first term? Go. Okay, I know you're not completely done, but give me your ideas. So we were having a discussion back over here, and they said, like, what's D? Okay, so, and we talked about that, and then we said, so basically we came to this conclusion that every time we want to write an explicit rule like this, we want to make it so someone can plug in this and get this, which means we need these two pieces of information. It's like writing an equation of a line, right? You need a point, and you need a slope, right? And then you can write the equation in whatever form they want, but you need those two pieces of information. And sometimes they just hand them to you, and sometimes you have to work for them. This is the same exact process. As a matter of fact, our equations actually end up looking like lines when it's arithmetic, just like your data did with your stacking cups, because they kind of have this constant increase or constant decrease, like slope of a line. Okay? So the question becomes, how do we take those two pieces of information and determine first term and common difference? So what are some ways that you guys went about this? Yeah.
So I plugged in A7 for AN, which would be 20, and then I plugged and then I got that down to 2 variables.
Okay. 20 equals A1 plus 16.
Yeah. And then I did the same thing with the other
Sure.
and then once I got that down to two variables, I used that, and then I used the mapping system of equations
Uh-huh.
to solve the two variables, and then I solved for T and A1.
Perfect. So one method of doing this. Every time they're giving you a pair of information, they're giving you something to plug in. This is a lot like if they gave you 2 points and asked you to write the equation of a line. You could plug the 2 points into a slope formula. You could plug the 2 points into the actual equation, and you could have m and b left for you to solve for. So basically, one way to do this is to recognize that that means put 7 in for n, and an is 20. Put 23 in for n, and an is 52. And do each of those things and have a system of 2 equations with 2 unknowns, which you can solve by substitution or elimination. Okay? Did anybody go about it differently? Yes? No, it's okay. It's okay. Yeah?
The difference between 20 and 32 is, or 52 is 32.
Okay.
And the difference between 7 and 23 is 16.
Okay.
So then from there you figure out that D is equivalent to 2. And you could just count down from A7 until you get to A1 and figure out the base.
All right. Did you guys get what he was saying? Since this is arithmetic and you're adding the same amount every time, he looked at it and said, how much did it go up? So I started at 20, and then later on it was at 52. So it went up a total of 32, right? But how many spaces did it take for it to go up a total of 32? Well, that number was in the 7th space, and that number was in the 23rd space. So it took it 16 spaces to go up 32 units, which means 32 divided up into 16 spaces, because we know it's equal because it's arithmetic series, gives us a common difference of 2, and he said you could work backwards from 7 to get your A1 that way.
I did the same thing, but I got it differently with A1.
Sure.
I just took the formula and plugged in the term 7 for n, and then plugged in the difference to get A1.
Perfect. So she used his idea of thinking about how to get the common difference, but then she kind of combined that with the method we saw earlier of understanding that plugging in 7 meant 20 went here. So she kind of took that equation. I know that if I have 20 here, that came from plugging in 7. But now she also knows that the common difference is 2. And so she has 20 equals A1 plus 12, and A1 is equal to 8. Right? Okay. Over here, you would solve for A1 and D that way. So either way that you solve it, we're figuring out that A1 is equal to 8, and D is equal to 2. That's not my final answer, but those are the key pieces of information to then write the most accurate rule. So my rule, okay, depends on A1 being 8 and D being 2. And then I'm just going to distribute and combine like terms to kind of get it in the simplest form. So I'm getting 6 plus 2n or 2n plus 6. Okay, either way, that's fine. And if you have some terms in your sequence, you could always go back and plug it in if you thought you made an error somewhere and make sure it makes sense with the given information. Okay, like that I plug in 23, I actually get 52. And then they said for part B, so this was for part A. Okay. For part B, yeah, sorry. Yes. So she's using this idea. A7 equals 20. So when you plug 7 in for n, you're supposed to get 20. So she's doing this work right here. Okay? So she has this equation, but they've already figured out from this arithmetic here that D is equal to 2. So she uses that equation but plugs in 2 automatically for D, and then that allows us to get that A1 is equal to 8. Is that all right? So it's a combination of she did this work, okay, and she did this work, and then she plugged the difference into there to figure it out. Is that good enough? Yeah? Okay. So here's my rule, and then part B says, find the value of n for which a sub n equals 44. What are you looking for when you're looking for n? Totally appreciate it, but you've already talked to me twice today. We're going to make some of them speak out loud to make sure we know where we are here. What are you finding? They're saying find the value of n. So I get it. You're finding the value of n. What does that represent? Yes. Good. The place it comes in the sequence. Which term is actually equal to 44? And judging the fact it's increasing, and they already told me the 7th term was 20 and the 23rd term was 52, I would bargain it's somewhere between the 7th and the 23rd term, just kind of as a mental thing to help me be confident in my answer later. How mathematically, now that I have this rule, can I figure out exactly what term is going to be equal to 44? Yeah.
Plug in 44 equals 8 plus
Yes.
n minus or times 2.
Yes, but I'm going to use the simpler version. Is that okay? That I got after I combined all the like terms together. So I'm going to plug in 44 for the spot where an was, because I know 44 sits somewhere in the list. And I'm going to set it equal to the rest of my rule. Okay. Then I'm going to subtract 6 and divide by 2. And I'm getting that n is equal to 19. Does it make sense with what you know about this sequence that the 19th term could be 44? Yes, so I feel confident in that and okay with that math. Okay? Questions? Yeah. Perfect. So he went back to this idea of just understanding the pattern really well. And so he just went, 44 is pretty close to 52. How far is 44 away from 52? And he figured out it's 44 minus 52, 8 away from 52. And so then he said, okay, it's 8 units away, but I was using common difference of 2. So how many times did I have to use 2 to get 8 away from 52? 4 times, okay? And then he figured out which term then is 4 terms below the 23rd term. That would be the 19th term. There's totally an intuitive way to do this if you really latch onto the patterns. So there's not a right or a wrong. You just have to make sure that you're getting to the place where you are able to get the right answer. The pathway is accessible for multiple ideas, okay? All right, let's see if there's anything else for us to do. All right, we're not going to do example 3, okay? Because there will be a problem like it in the homework, and we'll go over that one specifically.